So we finally get back to inverses. Now we're going to get into more detail about the inverses. And what we're looking at is these are the graphs of all six trig functions. And so what we're going to do now is inverses are a couple of things. Inverses have the reflection over, remember that they're symmetric over the y equals to x. So we know that what's going to happen with the inverses is that the y becomes the x and the x becomes the y, and the reflexive over the y equals to x. And so you're just switching the accounts on there. So when we're looking at this, in order for them to have an inverse, they had to be 1 to 1. So every function had to be 1 to 1. I know it's coming back, I hope. So 1 to 1 means that they have to have inverses. That means they're reflected across the y equals to x, and therefore an inverse exists. So here, these are not 1 to 1. So here in order to be 1 to 1, it has to pass the vertical line test, and it also has to pass the horizontal line test. Well, all these are functions, so they pass the vertical line test, but they do not pass the horizontal line test. And that's where we have to force it. We're going to force them to pass the horizontal line test. So if I'm looking at it, because it repeats on infinitely over, up and down, where do we actually stop it? And where I stop it, and where you stop it, and where all the scientists stop it, and everybody in the world stops it should be the same and has to be the same, because otherwise you're going to get some different answers and different angles over here. We don't want it to be all the way over here. We want it to be right around the center. And so we want to look somewhere around the origin that's going to make it look nice. And the way that we do it then is if for this one here, which is the sine function, which you should recognize by now, this is the sine function. We want this to keep going, and it's not going to repeat here. And then this one here is not going to repeat here. So if I just restrict it between these two dotted lines, so what I want is just this right here, none of it is going to repeat. So this one here is going to pass the vertical line test as well as the horizontal line test. So if I just cut at the dotted lines and I restrict it just here, it is now going to be a one-to-one function, and therefore the inverse is going to exist. So down here, what do we restrict the domain to? And the domain is going to be restricted. And here, if you look at the bottom, these are radians, which we're going to get into soon. So I put above the equivalent degrees to it. So pi over 2 is equivalent to 90 degrees. So when we're doing this right now, we're going to fill it in with the degrees. So from negative 90 to 90 is where I did the restriction. So we're going from negative, so it's going to be, hold on, from negative 90 degrees all the way to positive 90 is where the restrictions are going to be. And so that's the domain that we've restricted on it. What quadrants are they? Well, this is easy to see on the quadrants there. And one of the ways to look at the quadrants is from 0 to 90 on a unit circle is always going to be quadrant 1. From 90 to 180, that is going to be quadrant 2. From 180 to 27, that is going to be quadrant 3. And from 270 to 360, that is going to be quadrant 4. Now, going backwards, it's a little different. So going backwards, if you remember on the unit circle, this here is 0 degrees, but going this way, that's going to give me negative 90, which is the same as 270. So when I go back this way, this is actually quadrant 4. And then this one here is quadrant 3 because we're going in the different direction. This is quadrant 2 and this is quadrant 1. So we're actually going in a different direction. And so when we do that, um, one of the things is that the quadrant 4 and this quadrant 4 are not the same quadrants, because the quadrant 4 is going all the way around, and this one here is just coming straight down here, where it's going to be from 0 to negative 90, while the quadrant 4 is 270 to 360. It's all the way over there. So instead of calling it, it is quadrant 4, and so we could remember that it's quadrant 4, but I like calling it, let's put that back. I like calling, and my x-axis just erased. I like calling this, not these quadrants. I like calling this one quadrant -1 and quadrant -2, because this one here, 4, and this one being 4, they're not the same because they have the 6 different degree angles. Even though on the unit circle, unit 1 and unit 4 and quadrant 4 and quadrant -1 are exactly the same. They fall on top of each other. But over here, it just gives it a different value because the answer should be between 0 and -90 and never be between 270 and 360. So that's how you will restrict the sign, and that's the interval. So this one here is going to be in quadrant 1 and also quadrant 4, but I'm going to put that in parentheses and call it quadrant -1. Okay, and so if sine is restricted there, everything that happens to sine is going to happen to cosecant. And this is what cosecant looks like if the sine is not in there. And so notice how it starts at 1 and goes up to infinity. We've talked about that. But if sine is restricted between the 90 and the -90, then so is the cosecant. So this one here is going to be restricted there, and we're forcing it to be 1 to 1, and so they're going to have the same thing there. And so whatever we say up here is going to be the same. So this is going to be the same. I'm just going to write down same as sine. Okay, and then going back to the tangent is going to be, this one here is the tangent, and these here are asymptotes. You notice that these here, the asymptotes are in there. They're not usually there. So this one here, just put in the asymptotes there, and then these ones here are the asymptotes as well. So they're supposed to be dotted, but they're not. The curve for the tangent is actually, the curve is actually these curves right there, and the other ones are the asymptotes. So same thing up here, the curves are the parabolas on there. Okay, so now we're going from this one here. Where is it going to be 1 to 1? And it's really nice because it is going to be 1 to 1 in the same place that sine is. So all of these are going to be the same. So the restriction is going to be the same as sine, and that makes it 1 to 1 as well. And the quadrants follow the same way. Now, cosine is a little bit different. We figured out that sine, cosecant, and tangent all work on the same restrictions. Cosine is restricted a little different because if I were to restrict the cosine, if I were to restrict it between -90 and +90, notice how it would not pass the horizontal line test. So we are not going to restrict it there. And so the way that you do it is that it will be restricted between, let's undo that and let's get this one here. That is going to be restricted between 0 and 180 degrees. And so if we look at that, that one now is going to pass the horizontal line test. And so then we are good to go. So what quadrants are they? So the quadrants that we have there is that this is going to be quadrant 1 and quadrant 2. This is quadrant 3 and quadrant 4. Notice how none is there and none is going to be on the other side. So we're only restricting it to 1 and 2. So 1 and 2 is going to be, the domain is going to be from 0 degrees to 180 degrees. And then the quadrants are going to be quadrants 1 and 2. And if cosine, then secant, and also then cotangent are going to be the same. So they're going to be the same restrictions, same as cosine of theta, and this is also same as cosine of theta. Very good. So when you have here is you have the cosine of theta is equal to the negative 0.7071. Notice how that one there is now the trig ratio, and it's not a fraction, but it's still the trig ratio because you have your trig function and you have the angle here right there. So what we're trying to find out here is they're giving them some more information. The terminal side, which means that it starts on the standard position angle, the terminal side of that angle lies in quadrant 3. So the terminal size of theta is going to be in quadrant 3. So we know that if we were going to draw it, it would be in this quadrant right there. And so what we want to know is what angle is going to make that. And so in this case, you are going to need to use a calculator. And so the way that you do and find the information there is that we know that it's in the third quadrant because it's telling us there. And this one here is negative, so it could have been in the second quadrant or in the third quadrant. But because it's specifically here telling us it's in the third quadrant, that's where the trig ratios are going to be negative. That's what we're going to do. So now when we do this, we are going to use the cosine of theta is equal to negative 0.7071. And so we are solving for the angle and we are using our calculator. Our calculator is going to follow the information that we have above over here. And so when we're doing the cosine inverse, that's the restriction that we're putting it on here. So the restriction is that the angle that's going to be given to us in our calculator is going to be either quadrant 1 or in quadrant 2. So the angle that's going to be given to us is from 0 degrees to 180 degrees. So when we put this negative 0.7071, it is not going to give us the angle in quadrant 3. It's going to give it to us in quadrant 1 and in quadrant 2 because that's where it's restricted. So cosine is restricted just on these two, so therefore that's where the angle is going to give us. So when we enter it into our calculator, we are actually going to get the angle to be approximately 134.999 4505. I'm just writing the whole thing. Of course, you could do 135 approximately because these all round up. So that is the angle that we have in quadrant 2 because that's going to be from 90 degrees to 180 degrees. But the one that we want, it has to be in quadrant 3. So that means that we are going to do a little bit more. What do we need to know that it's in quadrant 3? Well, the 134 is from here to here is 134.9999. So we need to know the reference angle. So the theta for the reference angle is going to be, when I find it, it's going to be 180 degrees minus 134.999 degrees. It's going to give us approximately 45.0005 degrees there. So that's our reference angle. So in order to find the angle here, this is the reference angle and that's the reference angle, the 45, and so therefore that's going to be the 45. So when we find the actual standard position angle in quadrant 3, that is going to be when we do 180 degrees plus the 45, which is the reference angle, 005. And so our regular angle in quadrant 3 is 225 degrees, 0.0005 degrees. So that is the angle that we want. So when cosine of theta was the cosine of 225 degrees, is going to give us negative 0.7071. And there we go. So another question here. This one here is the tangent, and this one here is going to be a negative trig ratio, and it's falling in quadrant 4. So if we have it in quadrant 4, the tangent is going to be the same thing, tangent inverse of negative 0.7813. Now the inverse is restricted to quadrants 1 and, I'm sorry, negative 1 and 1 here. So this is going to be in here 1, negative 1 and positive 1. So between negative 90 and positive 90. So when you do this, if it's a negative, it's actually going to put it in this quadrant right here. And so when it puts it in this quadrant or this quadrant right here, when it puts it in this quadrant, it's going to be from 0 degrees to negative 90 degrees. So when you put this into your calculator, you are not going to get an angle between 270 and 360. The angle is going to be between 0 and negative 90. So when I put that into my calculator, we end up with negative 38.0005 degrees there. So that's this reference angle there. Now it is negative because of the direction that we're doing it, but reference angles are always going to be positive. So when I put the R there, this automatically becomes a negative 30, a positive 38, and that is the reference angle there. Okay, so now in order for us to find out the standard position angle that's in the fourth quadrant, that means that we are going to take this angle from here and go all the way over here. So we do want it in quadrant 4, not in quadrant -1. And so the way that you do that is you're going to do theta, and you're going to do, I want the whole entire thing minus this reference angle. So the whole thing is 360 degrees, and I am going to get rid of the 38 degrees there. And so what that gives us is the standard position angle of 321 degrees there. And so always look to the directions to see how many units we have there. So the standard position angle of theta, that when I put tangent of 321, it's going to give me negative 0.7813. And then this one final one here, we're talking about the secant. The secant is going to be negative 1.83. That's the trig ratio. And we want it in quadrant 3. So if we look at that in quadrant 3, we know that secant and cosine are the same. And so here is the only one that's positive is tangent. So everything else is negative. So secant is going to be negative in there, which is perfect because it's a negative trig ratio. So we're good there. Now, the angle that we're doing here is going to be from that we want is the standard position angle from there, but we're going to need a reference angle to help us along. And so when we do this, you could do in the TI Nspire, you could do theta is equal to the secant to -1 of negative 1.8391. And then when you put it in your calculator, you get an answer. The problem there is that the 84 doesn't have that. And if your TI Nspire is in testing mode, you're not going to be able to do that either. So we know that the cosine of theta is going to be pretty much the same thing as that, but it's going to be just the reciprocal of that. So we could just put this in here. And so what we could put in our calculator is the cosine inverse of 1 over negative 1.8391, and that is going to give us the same answer as putting this into the TI Nspire. And so the theta that we get there, because cosine is restricted between quadrants 1 and, undo that. If it's restricted between quadrants 1 and 2, that means that the angle that we get there is going to be, because this is negative, is going to be given to us in quadrant number 2. So when we do the inverse of that, we end up getting 122.938888990. And so that is the angle in quadrant 2, but we don't want the angle in quadrant 2, we want it in quadrant 3. So what do we need to find? That's this angle right here that's given to us. And so in order for us to do that, we need to find this reference angle, which then will be that reference angle. And so what we do is we do theta is going to be 180 minus 122.93 ... degrees, and that is going to give us 57.06111 as a reference angle. So that's our reference angle there. So in order for us to get the standard position angle from the initial all the way to the start there, what we're going to do to get the real angle here is going to be, I guess I could do that in pink, and let me do that really quickly. And so the real angle that we want is we're going to do the whole thing, 180 plus the reference angle, which is going to be 57.06110. So theta is going to be 237.06 degrees, which makes sense because in the third quadrant, we're doing 180 to 270. So it has to be in between there, and that is our angle. Very good.